Since 1983, palladium-catalyzed carbon-nitrogen couplings have been reported. However, most methods suffered from limited substrate scope and functional group tolerance. Stefan Buchwald and John Hartwig have been credited, whose publications between 1994 and the late 2000s established the scope of the transformation. The development of the Buchwald-Hartwig reaction allowed for the facile synthesis of aryl amines, replacing to an extent harsher methods such as the Goldberg reaction, nucleophilic aromatic substitution, while significantly expanding the repertoire of possible carbon-nitrogen bond formation. Because of the ubiquity of aryl carbon-nitrogen bonds in pharmaceuticals and natural products, the reaction has gained wide use in synthetic organic chemistry, with application in many total synthesis and the industrial preparation of numerous pharmaceuticals. Industrial applications include alpha arylation of carbonyl compounds such as ketones, esters, amides, aldehydes, and nitriles. Hartwig-Buchwald reaction, an easier approach of adding this amine to an aryl group. So how do you form a carbon-nitrogen bond? So we need aryl halide and an amine in the presence of this palladium catalyst. And either you can use a Hartwig base or Buchwald base. For Hartwig base, it's lithium trimethylsilylamine, and for Buchwald, it's going to be sodium tert-butoxide. So let's look at the mechanism. First thing is going to be that palladium acetate, the oxidation state of 2, is undergoing reduction to form palladium 0. So your ligand is going to be now triphenylphosphine, which is a neutral ligand. Second step is going to be oxidative addition, where you break this carbon and bromine bond, and then you form this complex. So now it's palladium 2. Step 3 is going to be ligand exchange. Your amine is going to come in and exchange for this triphenylphosphine, which is going to come off. Now this complex is formed where you have a protonated amine. So we need a base, either Hartwig or Buchwald. And the fourth step is going to be reductive elimination, where a base is going to come in and grab that proton and also expel that bromine in that way. Now the last step is going to be reductive elimination. So that amine and that aryl is going to have that carbon-nitrogen bond formation, and that's going to come off, and now you're left with this palladium 0, and the cycle will continue.